Hello everyone, welcome to the course of linear algebra. So this is the part 1 of the linear algebra. So topics we are going to discuss, I will write here. So first topic we will discuss about the basics of matrices. Basics of matrices. Second topic would be a rank of a matrix. Rank of a matrix. Third topic would be system of linear equation. Fourth Fourth one be eigenvalues and eigenvectors. Fifth topic would be special matrices. Sixth topic would be LU decomposition. Seventh one will be minimal polynomial. Minimal polynomial. Okay. So we will start with the basics of matrices. So first we will start with the basics of matrices. So suppose we have two matrices. Suppose we have two matrices. First one is matrix A, who is which is n cross M matrix, means M row in column, and second one is B matrices, which is having P row Q column. Okay, suppose these two matrices we have. So using these two matrices I will explain some properties of matrices. So first one property is, suppose we want to multiply these two matrices, that is matrix A and this matrix A and matrix B, we want to multiply it. So there is one condition when we can multiply these two matrices. The condition is, so we will if we want to multiply these two matrices, that is matrix A and matrix B, so it should follow one condition. The condition is like, suppose this matrix A, which is M cross N matrix, and this is matrix B, which is a P cross Q matrix. So column of A matrix should be equal to number of row of B matrix, that is N should be equal to P, then only we can multiply matrix A and B. So if we multiply matrix A and B, we will get matrix AB, which will be M cross Q matrix. This M cross Q matrix. Okay. So this will be M cross AB matrix will be M cross Q matrix when N is equals to P. So this is the first property. Second property is, suppose BA matrix is there, which is which will be p cross n matrix. Okay, so suppose this matrix exists, multiplying b matrix b to matrix A, we will get matrix BA, which will be p cross n matrix. Again, following this same property 1, so we will getting BA matrix, which is having p cross n. So this will only exist. This is only exist when Q is equals to M. See here, B matrix is P cross Q matrix and A matrix is M cross N matrix. So we want to multiply these two matrices. How it is possible? When number of column of Q matrix is equal to number of row of A matrix. So means Q is equals to M. Then only we will get, if Q is equals to M, then only we will get B A matrix, which will be P cross N matrix. P cross N matrix. Okay. So this will only possible B. We want to multiply matrix B to the matrix A when it is possible, when number of column of B matrix equal to number of row of A matrix, which means Q is equals to M. So this Q is equals to M, then only we will able to multiply BA. So after multiplication we are getting BA matrix, which will be P cross N matrix, means this P cross N matrix. Okay, so this is the second property. Now talking about the third property. Suppose after multiplication we are getting AB matrix, and after multiplication we are getting BA matrix. So these two matrices is not equal. Okay, AB matrix and BA matrix, it will not be equal matrix. So it is not commutative. It is not commutative. Okay. The fourth property is, suppose we are after multiplication A matrix to the B, we are getting AB matrix, and we are multiplying AB matrix to the matrix C, and again we are multiplying B matrix to the C matrix. We are getting BC matrix, and we are multiplying it with matrix A. So these two matrices will be equal to each other. Okay, this is the fourth principle. The fifth principle is, suppose after multiplication matrix A to the matrix B, we are getting zero matrix, means null matrix. So suppose AB is 0, so it need not be implied that it need not be implied that matrix A is 0 or matrix B is 0. It need not be true. It might be true, but it is not compulsory that matrix A is 0 or matrix B is 0. If AB is 0, it need not be true imply. So we are see one example. Suppose for example matrix A is -1 0 0 0, and matrix B is 0 0 2 0. So this is matrix A, matrix B. Now here two row, this is row 1, row 2. So we are having two row, and this is one column, this is second column. So it is having two row, two column. It is 2 cross 2 matrix. Similarly, it is also 2 cross 2 matrix. Here it is 2 row and 2 column. Okay, so 2 cross 2 matrix. So if you want to multiply AB matrix, then what it should follow? It should follow number of column of A matrix should be equal to number of row of B matrix, means these two should be equal. So it is equal, so we can multiply AB. After multiplication of AB, we will get 2 cross 2 matrix, 2 cross these two matrix. So we will get 2 cross 2 matrix. So how we will multiply? So it will be first row first column, first row second column, second row first column, second row second column. So multiply first row of A to the first column of B. So first row of A is -1 and 0. So -1, first column is this one. So -1 into 0 plus 0 into 2. We will get 0. Then again multiply first row of A to second column of B. So first row is -1 0 and second row is 0 0. So here it will be -1 into 0 plus 0 into 0. Okay, again second row of A to the first column of B. Second row is what? This is second row, this is second row. So 0 into first column of B, 0 plus 0 into 2. 0 into 2, this is the first column of B. This is the first column of B. Again first row of A, no sorry, second row of A to the second column of B, means 0 this element to this element plus this element to this element. So we are getting here 0, this total is 0, this total is also 0, this total is 0, and this one is also 0. So we are getting AB matrix 0 0. So see here, AB is 0 matrix, but it is, see, we are getting AB is 0 matrix. Here it is 0 matrix, but is it like A is 0 matrix? No, it is not 0 matrix, because A is -1 0 0 0 and B is also not 0 matrix, because its first row is 0 0, second row is 2 0. So it is not true. If AB is 0 0 matrix, it need not be implied that A is 0 or B is 0. Okay, so this is the proof. Now we are going to see the third property, sorry, sixth property. Suppose let A matrix be M cross N matrix, okay, and let B matrix is N cross P matrix, okay. So the product AB matrix will be M cross P matrix. Why? Because these two are equal. So we are getting AB matrix of M cross P matrix. So it involves, now we want to know number of multiplication. So number of multiplication in this process will be number of multiplication will be M into N into P. This will give you number of multiplication involved in AB matrix. Means you multiply M into N into P. So you will get number of multiplication. Now suppose you want to know number of additions required to get the matrix AB. So number of additions will be M into P into n minus 1. So this will give you number of addition. So we'll see one example here. Suppose A matrix is 3 is to 4 matrix and B matrix is 4 cross 5 matrix. Okay, so we want to know the number of multiplication involved in this and number of addition involved in this. Okay, so how we will know? So using the formula, so using the similar formula, same formula which I have described here. So number of multiplication will be 3 into 4 into 5. Okay, this is similar to, sorry, okay. So this is similar to this. Suppose this is m into n and this is n into p. So number of multiplication will be this is similar to m into n and this is n into p, means n cross p. So number of multiplication will be what? Number of multiplication will be number of multiplication will be m into n into p. So here it is 3 into 4 into 5, this will be 60. So 60 multiplication will be required. And number of addition, number of additions will be m into n minus 1 into p. So m is 3, n is 4, that is 4 minus 1, and p is 5. So we are getting 45 number of additions. Okay, clear? So another one question. Suppose another example. Suppose you have a matrix which is 2 cross 3 matrix, matrix B which is 3 cross 4 matrix, matrix C which is 4 cross 3 matrix. Now you want to know, now you're multiplying A, B, C. So you want to know number of addition and number of multiplication involved in getting matrix A, B and C. So there is two chances how you get ABC matrix. You multiply A with the with matrix BC, or you multiply AB matrix to the matrix C. So in these two ways you will get matrix ABC. This matrix you will get. So you need to check number of multiplication involved in these two process. So in these two process, suppose if you getting BC matrix, so what will be the number of multiplication? Number of multiplication to get the BC matrix, it will be 3 into 4 into 3. So here you will get number of multiplication 3 into 4 into 3, and BC will be 3 cross 3 matrix. BC will be 3 cross 3 matrix, and number of multiplication will be 3 into 4 into 3, that is 36. Total number of multiplication to get the BC matrix is 36. Now you multiply BC matrix to the matrix A. So matrix A is 2 cross 3 matrix, matrix A is 2 cross 3 matrix, and matrix BC is 3 cross 3 matrix. Now you number of multiplication to get A BC matrix, to number of multiplication to get ABC matrix is 2 into 3 into 3. So 2 into 3 into 3. This is how much? This is 18. This is 18. So finally you got the A, B, C matrix. And so total number of multiplication, how much? That is matrix, that is 36 plus 18 to get the matrix A, B, C from this process. Okay. So you add 36 to 18. Total number of multiplication is 54. Total number of multiplication, you add 36 to 18, you will get total number of multiplication 54. From the process, this process. Now similarly we will see from this process. Okay. So A matrix is 2 cross 3 matrix. Matrix B is 3 cross 4 matrix. Matrix C is 4 cross 3 matrix. So we want to get AB matrix. So AB matrix, this 3 and this 3 is equal. So we will able to multiply AB. And after multiplication we will get 2 cross 4 matrix. 2 cross 4 matrix. Okay. To get AB, AB matrix, how many number of multiplication is required? That is M N P, number of multiplication. So M is 2, N is 3 and P is 4. So 2, 3, 4. The total number of multiplication is 24 in first step. Now you multiply AB matrix to the matrix C. Now you can multiply because 4 here and 4 is here, so these two are equal. So you will be able to multiply AB matrix to the matrix C, and this matrix will be 2 cross 3 matrix. Okay. So number of multiplication involved in this MNP. So N is what here? M is what here? 3. No, M is 2, N is 4 and P is 3. So 2 into 4 into 3, it is again 24. So total number of multiplication is this 24 and this 24. So add you these two 24 plus 24, total number of multiplication is 48. In this, from this process we are getting 48 multiplication. Okay. So suppose examiner asking you minimum number of multiplication. So minimum number of multiplication is will be 48, because maximum number of multiplication is 54, minimum number of multiplication is 48. So you can write the minimum of multiplication involved in the product ABC is 48. Okay, clear? Now we will start another topic, that is subtopic trace of matrix. Trace of matrix. Okay. So suppose there is matrix A which is n cross n matrix, means matrix A which is having n row and m column. Let A matrix be n cross n matrix, means n number of row and n number of column. Okay, so this is matrix. So matrix A is suppose matrix A is n cross n matrix. What does it mean? Means this matrix having n number of rows. This is first row, this is second row, this is third row, dot 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 n row. It is having n row. Similarly, it is having n column. First column, second column, dot 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 n column. So n row, n column. Okay, clear? Suppose. Okay, so this is n cross n matrix. So first element is a11 means a12 dot 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 a1 first row up to n. a21 a22 dot dot a2n. Similarly, last column, last row is nth column, which having first last element is nth row first column. This is n cross n element. So this principal diagonal element is here in this matrix. We can tell you the principal diagonal elements will be these elements will be principal diagonal element. Okay, so principal diagonal element will be 1 1 a 2 2 dot 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 a n n. This will be the principal diagonal elements. So you want to know the trace of A, means what is the trace of matrix A? It is sum of principal diagonal element. Trace of A is sum of principal diagonal element. Sum of principal diagonal elements, that is a11 plus a22 plus dot 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 a n n. Okay, so we'll see one example here, one example problem. Suppose matrix A whose elements are 1 3 4 2 5 7 3 8 9. Now you want to know the trace of A, trace of this matrix A. So trace of A will be sum of principal diagonal element, means these elements. You just add these elements, diagonal elements, you will get sum of principal diagonal element, means trace of A you will get, that is 1 plus 5 plus 9, you will get 15. So trace of A is 15. So we'll see some properties of traces. So properties of traces is, suppose trace A plus minus trace B will be equal to trace of A plus minus trace of B. This is first property. Second property is these three are properties of traces. So trace of A is equal to trace of A transpose, and trace of AB is trace of BA matrices. So A transpose, you will see what is A transpose in further lectures. Okay, we will see you in the next lecture.